Hello everyone, and welcome back to the last video here in this series on our inference for proportions unit in AP Statistics. This one specifically, this video doesn't actually apply to just proportions. However, in the AP course and exam description, they do cover errors in hypothesis testing in the inference for proportions unit. And I think the reason for that is that you deal with proportions first. And so they want to make sure that you have a good understanding of what potential errors can occur early on as opposed to after you've done all of the hypothesis testing. So let's jump right into it. We're going to talk quickly about the two different types of errors today, and then also how you describe them and what some consequences may be. So statistics people are so clever. We have two types of errors, type 1 and type 2. And so a type 1 error is when we reject the null hypothesis, but the null hypothesis is true. Think about this as a false positive. That is the way that I like to think about it. A type 2 error is when we do not reject the null hypothesis, but the null hypothesis is false. So in this case, this is the equivalent of a false negative. Now, context dependent will tell you which one of these is worse, right? It depends on how your hypotheses are written, and it also depends on the consequences. Now, one other thing that's important here is the probability of a type 1 error is just equal to your significance level. The probability of a type 2 error is equal to beta. Now, the thing about beta is that it's impossible to calculate without knowing the population numbers, right? And so, like I said before, which error type is worse depends on the context. Right? The medical field, we tend to err on the side of false negatives being worse. But again, it depends on how you write your hypotheses. And depending on which error type has a worse consequence will also affect how you set your significance level. If a type 1 is worse, I'm going to make my significance level really, really small. So that way, if I reject my null hypothesis, I'm very sure that I did so correctly. If a type 2 error is worse, I'm going to make my significance level really large, like 0.1. So I reduce the chance of not rejecting when I should in the first place. And so there's a inverse relationship between the two. As you increase the probability of a type 1, you decrease the probability of a type 2. And so none of that is like good or bad. It's just an understanding of depending on the type of consequence that is going to be worse will affect how you set your significance level. The other very important thing is that in any one given problem, you can only make one type of error. If you reject your null hypothesis, you're either correct or you made a type 1 error. If you don't reject your null hypothesis, you're either correct or you made a type 2 error. You cannot make both. And the other important thing here is, again, very similar to bias in our sampling unit. None of this is on purpose. It just so happens that based on the sample that you got, you ended up doing one of these things when you shouldn't have. So let's take a look at an example problem and like, how do I interpret error types here? So if we look at this question, this is a free response question, I forget from what year, but we have a random sample. This should say alpha. This is a copy and paste error here. And so in this particular case, they're asking me to describe a type 2 error, right? I just copied and pasted down here. So a type 2 error, if I look in this context, means I don't reject, but I should have. And so in this case, a type 2 error would be would be not finding evidence to reject my null hypothesis, but in fact, less than 35% of people could pass the test. Now, in this case, this was about the amount of people that could pass a physical fitness test in this particular town. So notice, the way that I phrase it is the exact definition. I don't find evidence that the true proportion is less than 35%, but in fact it is. Now it says to describe a consequence, make sure it's a physical thing. That's what this says down here. Make sure that your consequence is a physical thing. So in this case, what's going to happen is that the rec department won't fund more fitness programs but the town needs them. So this is what I mean when I say a physical thing. Because a lot of times people want to interpret the error of, oh, they got, or a consequence of they got inaccurate results, and so it's not valid. But that's not a physical thing, right? In this particular case, what is actually going to happen is that the recreation department isn't going to fund these additional fitness programs, and the town needs them to get more people to be healthy, right? What I put on this thing, think about the school board question. We did a question a long time ago about non-response bias in a school board survey and how 98 people, or 76 out of 98 people responded yes to year-round schooling. And what would a consequence be? A lot of people said, oh, well, the school board would have inaccurate data. That's not a consequence. A consequence in that case is the school board will implement year-round schooling when it's possible that the majority of people don't support it. So in this particular case, that same thing applies. When you're interpreting an error, interpret it exactly how the definition is. If it's a type 1, I reject my null hypothesis, but in fact that null hypothesis was true, and insert the context from the problem. And for the for the consequence, make sure it's a real physical thing, not just some nebulous, inaccurate data, misinterpretation. Like, what is actually going to happen as a result of that data? So in this case, the rec department isn't going to fund these programs, but the town needs them. If this was about school board funding, or about after-school programs, or year-round school, or a professional sports team looking to increase their concessions prices, whatever it may be, make it a physical thing in the context of the problem. So, I hope that was helpful, and I'll see you guys in the next one.